Okay, so what we're going to look at today is lesson 4, which looks at the transformations of the exponential function. So we're going to look at how to graph exponential functions and apply different transformations to different base exponential functions. So we'll talk about that in a few minutes. So for our warm-up, we're told for the first one, given y equals f of x, describe in words the transformations that occur to the graph of y equals negative 2 f of 2x plus 4 minus 3. Now, the first thing I notice is that it's asking me to describe in words the transformations that are happening. So what I'm looking at are the different transformations that are happening to the base graph, which is y equals f of x in this case. And so there are many different transformations that are happening. I notice that there is a vertical reflection in the x-axis, a vertical stretch by a factor of 2. In terms of the horizontal transformations, I notice that there is something kind of weird happening here. I notice that the coefficient of x is not factored out, so I need to factor that out first before I start describing the transformations there. And so I'm going to do that now. So I actually have y equals negative 2 f of 2 x plus 2 minus 3. So once I factor out the coefficient of 2 in front of the x, I get 2 and then x plus 2. And so what this tells me is there's a horizontal compression by a factor of 1/2, a horizontal shift to the left 2, and a vertical shift down 3. So I'm going to write down those transformations. So vertical reflection in the x-axis, a vertical stretch by a factor of 2, a horizontal compression by a factor of 1/2, Okay, so remember that horizontal transformations are backwards. So although it looks like it might be a stretch, it's actually compression. And it's a compression by a factor of the reciprocal of 2, which is 1/2. We have a horizontal shift to the left, too. Remember, we used to call horizontal shifts in the trig unit phase shifts. Now we're not looking at trig anymore, so we're only calling them horizontal shifts again. So this is a horizontal shift to the left 2 units and a vertical shift down 3 units. Alright, so there's our transformations. Okay, the second question says, write the mapping formula for the function, and it's the same function that we looked at earlier. So we have y equals negative 2 f of 2x plus 4 minus 3. And again, before you write the mapping formula, make sure your equation is in factored form. So I have 2x plus 2 minus 3. And so if I write the mapping formulas, I know that normally I'm looking at x and y. And now my graph is going to be transformed based on the transformations that we saw in the first part of the warm-up. And so I can write some new mapping formulas. So in terms of my y values, because that's usually the easier one to work with, my y values have transformations that are away from where the x is. So here's all our transformations with the x, and these are our transformations away from the x that are outside of the brackets. And so what that tells me is my y values are going to be reflected, that's why they're being multiplied by negative. They're going to be stretched, so they're going to be multiplied by negative 2. And then they're going to be shifted down 3, so subtract 3 at the end. So there's my mapping formula for my y values. And I'm going to do something similar for my x values, except everything's backwards with x. So I'm actually going to multiply my x values by 1/2, since they're being compressed. and then I'm going to subtract 2 since they're being shifted to the left tube. Okay? And so there's our mapping formulas. You could have also written them as points, so you could have also written this as x and y being transferred to 1/2 x minus 2 and negative 2y minus 3. So that's just another way of writing a mapping formula. They both mean the same thing, just two different notations. Okay, so we're going to be looking at exponential functions today. So just to remind you of some of the things that we talked about so far in terms of exponential functions, we know that when you have an exponential function where the base is greater than 1, then that means that the more you multiply that value, the larger the value gets. So for example, picture something like y equals 2 to the exponent x. As I multiply 2 by itself more and more, the value of y gets larger and larger. And so what you end up getting is a graph that is increasing from left to right. We always talk about increasing and decreasing as we look at the graph moving from left to right. Okay? So you'll notice that the y values are getting higher as you move across. The other kind of function that we looked at is an exponential function where the base is between 0 and 1. So picture that something like y equals, let's say 1/4 to the exponent x. So notice that the base is a value that's less than 1, so it's between 0 and 1. And you'll notice that as you multiply this value more and more times, the denominator gets larger faster than the numerator, which results in a really large denominator and a really small denominator, and that ends up looking like a decreasing graph. Okay, so from left to right, the values of y are getting smaller and smaller and smaller, and you get a decreasing graph instead.